Hi, fourth grade. We're moving on to Soils, Rocks, and Landforms, Investigation 1, Part 2, Physical Weathering. So before we get on to the actual investigation, let's review what is soil. So through our investigation last week, we found out that soil is an earth material composed of different sizes of rock, such as sand, gravel, and pebbles, and humus, which is decaying plants and animals. For this investigation, I want to just focus on rock pieces and soils. So mountains are made of huge masses of rock. The Sierra Nevada, the Appalachian Mountains, and the Rocky Mountains are examples of these huge masses of rock. I'm wondering, if rocks start out as big as mountains, how do they get broken down into pieces small enough to be part of the soil? So here's our next focus question. What causes big rocks to break down into smaller rocks? So I want you to think about that for a little bit. What might cause that to happen? So if I were thinking about this, maybe, lightning striking, rocks tumbling down hills, or in a river during a flood, and then maybe just human activity, humans climbing on cliffs or whatever they might be doing in the area. But let's in particular focus on rocks breaking apart when they bang into each other. For example, when rocks are in the river, they tumble over each other during a flood, or sometimes there might be a landslide and rocks will tumble over each other and spill down hills. So that's what I want us to focus on for the first thought. But keep this focus question in mind. What causes big rocks to break down into smaller rocks? So we'll be answering that. Write that down somewhere so that you can have it in your mind to be thinking about as we go through this investigation. So to start with, we're going to focus on two different rocks. And we're going to think about the properties or words that would describe granite and conglomerate. So the first one I want to show you is a granite. So when you look at that, you can see there's a little bit of shininess in some of the pieces. You can see pink, gray, white speckles. It's fairly smoothish. So that is granite. And the second one I want to look at is conglomerate. Now look at that. It's made up of a lot of different colors too, like a rusty orange and gray, like tan. But to me, when I look at that, it looks like a bunch of different pieces of rock put together. And it's more rough. It's like rough and has more ridges on it. It's a lot more coarse. So now think about this. How can you break these pieces of granite and conglomerate into smaller pieces? I have this plastic jar with a lid. Think about what we might do. So could we put the pieces into the plastic jar and shake it for several minutes? Is that what you were thinking? I think we could. So for the next investigation that I show, there will be 4 pieces of granite, 4 pieces of conglomerate, 2 jars with plastic lid, 2 paper plates, and you will see what we will do in the investigation. So we know we talked about putting them into the jar and shaking them vigorously. I have 4 pieces of conglomerate rock that I'm going to put into this jar, seal tightly, and I will eventually shake vigorously for 2 minutes. I have 4 pieces of granite that I'm going to put into this plastic jar, seal tightly, and eventually shake for 2 minutes. So now we're going to dump out first the conglomerate pieces. Wow, look at that. There's a couple bigger pieces, but lots of dust and lots of smaller pieces. Now I wanted to bring out a piece that hasn't been messed with. It's just, we'll call it our control rock, so you can see the difference. So even with the bigger pieces that are left, you can see that they're just, I don't know, there's a difference. These are like pieces put together, and these are like what's left after you shake them up and the little pieces fall off. Okay, so that's the conglomerate. And then the granite pieces, all that you see there is just a lot of fine sand. And the other pieces look fairly similar to the control piece. They might be a little bit more smoother, a little bit more rounded than the control piece. So I think we can see that tumbling the rocks had an effect on them, especially on the conglomerate rock. Big pieces and sandy pieces, and they are more rounded, a little bit more smoothed out. And then on the granite, you just have little fine dust particles, and they do feel a little more smooth and a little bit more rounded. So let's compare the results from that investigation. The conglomerate had more and bigger pieces than the granite. It still had some of that fine dust, but then the pieces were broken down more. And the granite stayed pretty solid, but it had some fine sand with it as well. Now for both of them, they were both more rounded and smoothed off than the control rocks. So what is the effect of tumbling rocks? Well, they break down and they become more smooth. So let's talk about some of the vocabulary words. Now, when this happens, all the rocks, including mountains, exposed at Earth's surface break apart over time. But some rocks break apart faster than others. So if you ask the question, which would break apart faster, conglomerate or granite, then the conglomerate would break apart faster. So weathering is the geological word used to describe the breakdown of rock into smaller pieces. So when the conglomerate and granite broke down, that was weathering. Physical weathering in particular is when rocks break into smaller pieces without changing what the rock is made of. So that start of that rock, and even after we tumbled it, it was all made up of the same thing. Abrasion, or rubbing together, is one kind of physical weathering. So abrasion occurs when rocks fall, when rocks tumble in landslides, and when rocks hit one another, when they are pushed around by moving water, waves, and wind. So coming up next is the freezing investigation. In the previous part of the investigation, we looked at what happens when rocks are tumbled and they break apart. In this particular investigation, we are going to look at what happens when water freezes in the cracks of rocks. Water sometimes flows into cracks in rocks when the weather gets cold enough. Below 0 degrees Celsius, water can freeze. So we're going to pretend that this bottle is a rock. I have it filled with water all the way up to the top. I have a lid on nice and tight. So I'm going to wrap this in newspaper, nice and snug. Put it into the plastic bag. And tonight, or right now, I'm going to put it into the freezer and freeze it overnight. Oops, probably should have got the air out first. So this bottle acts as a rock. What do you think will happen to this bottle of water if I put it into the freezer overnight? This system will serve as a model of what might happen in the natural world. A model is a representation. So what happened to the bottle?
Oh!
The lid popped through the bag and the paper. All right, we're gonna take it out. Unwrap the paper. Ooh, it's tricky. I think we had some business going on here. Look at that, folks. Look at that. Wow, it's like frozen ice on the top of the paper. This is a lot more tricky than I thought it was going to be. Well, I want to get it all the way off if I can. I don't know if I can. Okay, this is going to be the best we can do, I think. Well, you can see that the glass cracked. The lid popped off. It's cracked all the way down because the paper's like iced over. So this would be exactly what would happen when ice freezes inside of rock. It starts to make it crack, just like the bottle. So as you could see in that investigation, what happened to the bottle was the bottle cracked in lots of different places. And the water expanded so much that the lid even cracked off. So let's find out why this happened. So when water freezes, it expands. It gets bigger. This means that the volume of the water increases. When it expands, the water pushes on things around it with a lot of force. The force was enough to break the bottle. In the mountains and other places where it is cold in winter, rocks are exposed to cycles of freezing and thawing. So when the water freezes in a crack in a rock, what might happen to that rock? Well, freezing water can break rocks into smaller pieces. This cycle of freezing and thawing, water flowing into cracks when it's liquid, and expanding when it freezes, is another kind of physical weathering that breaks rocks into smaller pieces. So let's go ahead and review vocabulary. Weathering, the process by which larger rocks crack and break apart over time to form smaller rocks. Physical weathering, the process by which rocks are broken down by breaking and banging. Abrasion, the rubbing, grinding, and bumping of rocks that cause physical weathering. Freeze, to change from a liquid to a solid state as a result of cooling. Expand, to get bigger, to take up more space. So your assignment is to answer the focus question. What causes big rocks to break down into smaller rocks? Please make sure you use the investigation when you're answering your question. So think about the rocks being shaken around in the jars. Think about the bottle breaking when the ice expands or the water freezes and expands. And please include that when you're answering your question. Submit it to Seesaw or on email.